Right, everyone has opened the interface? Everyone has SWAT, toolbox? Actually, click on the right click on the toolbox. If you are able to see the SWAT project setup, watershed delimiter, HR analysis, right input tables, you don't need to do anything. If you are not able to see that, right click on the toolbar and check mark the SWAT toolbox. Okay? If you are able to see it, no need to do anything, just leave it as it is. Okay? Anyone wants to move from batch 2 to batch 1? If she wants to do it, she will do it. Otherwise, you can complete test. Okay. Where is the folder that you have the data? Go to D folder, D drive. There is a folder called GAN course, and in that there is something called as input data. Input data has your temp, LULC, mask, observation flow, outlet, soil, Servo database, as well as weather data and management practices. Now, SWAT model application, we are going to do it for a US caption, Servo database, primarily because we have more data, but while setting up the model, I will also tell you how to do it for the Indian caption. Right? Basically, some database modification is what is required. Okay, go back to your ArcGIS. In the ArcGIS, first step is click on SWAT project setup. SWAT project setup. Click on new SWAT project. It will ask you a pop-up, save a current document. If you have no data, you can just say no. If you have some data, you can say yes. No. Say it just untitled, no. A pop-up window will open. One which says project directory. So when you are setting up a SWAT model, it creates files. And that files are saved in your this directory. That directory is what we need to give. So click on the folder icon next to the set project path. It will open to some folder. Go to D drive. Go to D drive. In this D drive, create a new folder. Create a new folder. Yeah, click on that. In that new folder, probably you can write your name without any spaces, without any special characters. You can type in your name. Don't put any special characters. Don't put any name. Sorry, any spaces. And then select that folder and say OK. Select that folder and click on OK. All are till here. where all your SWAT files will get saved. That is the folder where all your SWAT files are going to get saved, all the data that you are going to give. Now, it will create a project geodatabase, right? A database which will fill in all your SWAT information for your steady catchment. And that folder will have a name. It will have the same name as your directory. If you want to change it, you can change it, but just leave it. It's not necessary that you need to change it. Then all the raster storage that is there, all the maps that are giving, they get stored in a raster database, right? For example, DEM. From DEM to delineation, they will have a lot of raster maps getting generated. It is fill DEM, flow accumulation, flow direction. All these get saved in a database, what we refer to as raster store. You can, at any point of time, you can access these data from these datasets. And finally, to the personal geodatabase, SWAT database, right? We give a lot of input. Now, what does that input mean? And how do we refer to that? Is something that we get from this geodatabase. Okay? Click OK. You will get a message saying that project setup is done. Everyone is here? Everyone is here? Done? Okay. Now in the toolbox, click OK. In the toolbox, next to SWAT project setup, there is something called as watershed delimiter. Click on it. Next you will get automatic watershed delineation. Click on that as well. So while giving your project database file in the SWAT project setup, make sure that you are not saving it C drive or in a drive where your windows are there, or in a drive which you don't have permission. Right? Mostly wherever you have windows, some of the modifications you will not have the permission and it will show you some error. Usually set it up in a drive where you have all the permissions. Okay? And in this case we have taken the G drive. And when you are giving the name, don't give the name too long. Don't use any special characters, don't use any spaces, because ArcGIS is going to throw, or any QGIS will throw you some errors, which will, it's very difficult to sort out from the errors that it throws. Okay? Okay, a pop-up window opens up like this. Now, I'm sure Ashi would have told yesterday that whatever the data that you are giving must be projected. Right? You are formulating the three-dimensional data into two-dimension, and that requires a projection. Right? So all the data, whether it is DEM, whether it is land use, whether it is soil, you need to project it before using it in SWAT. Right? So let's start. We have given you a projected data. Click on Open DEM Raster. It will ask you whether you want to load it from the disk or select from the map. If you have already given it in the map, you can use it. Otherwise, go and select load from the disk. Click OK. Now go to your D drive where you have GAN course folder, which I have shown earlier. In that, input data. In that, click on DEM. Now you have only one raster data set DEM, you just say add. No, don't go to connect to the folder. Okay, so has the DEM loaded in your ArcMap? What's that? if you see here in your map, the dam is loaded. Okay, the dam is loaded, and it will also give you what is the minimum elevation and maximum elevation. It varies between 182 meters to 390 meters. There is something called dam projection setup. Click on that. When you click on that, it will tell you what is the cell size. The dam is 30 meter by 30 meter. It's SRT of 30 meter dam. On the right hand side, it will give you the spatial reference. What is the projected coordinate system? It is UTM, zone 16 and NAD 1983. Vertical unit is meters, and then all the geographic coordinate system and everything of your dam. Many a times before we take this, sometimes we may have to mosaic it. One tile may not be sufficient, right? This is also a mosaic. This is not one tile. We have already done that because that process usually takes far more time than setting up the model, right? So that is where we have already given you a process where mosaic. Okay? Click OK. As that unit you can make it meters. Won't make much of a difference. Just say meters. Okay? Now once you have a dam, there are two options. One is what we call as mask. Second one is burn. Actually, minimize this. So, in this particular dam, if you want to process the entire dam, then you don't need to mask it. But let's say your watershed lies in some part of the catchment, some part of this entire dam, and you know its location. It is better for the ArcGIS or the GIS or QGIS to simulate only that part. Because otherwise, 30 meter by 30 meter, it will start doing flow direction, flow accumulation for each and every pixel that is there. It takes a lot of time. On the other hand, if you say that I know only the location where my watershed is going to lie, right? Let's say you already have a watershed map shapefile, the boundary of your watershed. So I can mask that particular location. But always make sure that when you are masking, it should be, the area should be little larger than your boundary. Your boundary and the mask should not meet. Right? That means it is possible that the dam, some of the dam has been cut off. And that is what is the option of mask. So we are giving you a mask. So click on mask. So it will ask you three things. One is, if you already have a shapefile, you can load it from the disk. If you have a shapefile in your ArcMap already, you can select from the map, or you can manually delineate. If you select manually delineate, you can develop a polygon. Right? For simplicity, we have already done it. You click on load from there, load from the disk. Click OK. Go up. There is a folder called mask in your input data. Click on that and click on mask. Say add. So now you see your mask has been added. Right? The color of mask will vary from one system to another. Don't worry about it. Right? It's the shapefile. It randomly takes a color. Right? Here it is taken for black color. The second option is burn. Now let's say from the topo sheets you have already generated your channel level, or you have obtained a shapefile of the channel level. You can use that to correct your dam. Your dam may not, whatever the dam delineation that is coming or channel network coming, it may not match with the field. So if you have that information, you can burn in the into dam. So what it will do is, once you give the shapefile of your stream network, it will force the water to flow through that particular network. Right? So this is basically to correct some of the errors that the dam itself has. Right? So if you have a shapefile, which can be derived either from your topo sheets or through some aerial survey, through some drone survey, right, or through manual survey, you can use this burn-in option to correct your dam. Right now we don't have, so we just go with dam test. Right? Now once we call stream definition, One is by using the given depth, you can define subbasins and stream network. Second is, let's say you already have a predefined streams and watersheds. You have set up this model already before. You have a shapefile of subbasins and you have a shapefile of stream network, which must be ordered in a certain way. Right? That information should be there. Then you can go ahead and choose predefined streams and watersheds. Okay, then you can choose between the predefined streams and watershed. Otherwise, you can go with depth based. So when you are going with depth based, it will ask you to do flow direction and accumulation. Just click on that. So once it gets completed, you will get something called as end of then grid pre-processing. Is everyone here? Anyone still not here? Just click OK. Now here is where you have something called as area and number of cells. Now this area is basically the threshold area that is required for initiation of your stream. If you have first order stream, what happened? Babesh is having error. You are expert in SWAT, no? What is the problem?
Mark some problem is there.
What is the problem? Flow direction plugin. It should be deep yard course in the data. Where is it coming in models? Got it? Happening? Okay. So you have a threshold area. Now threshold area is the area for stream initiation. How does the stream get initiated? Anyone? You have a stream network. You say that it starts from here. Why does it start from there? How does it get started from there? Okay. Hmm. It gets accumulated, true. But what point do you say that channel is starting? Channel initiates. Channel is the point where flow occurs between two identifiable banks. It is basically your erosion process. It will form gullies. You know gully erosion? Yes? No? Heard gully erosion? So that erosion process leads to formation of channel. First order streams gets formed through gullies. So at what point that initiation? And how much area that drains to that particular point is this threshold area. This is the area that leads to formation of your channel. Now, ideally, you should keep this area such that your stream network is well represented. Again, if you keep it very small, not many channels will get delineated, leading to higher complex system. Let's just do a small experiment. Let's start with, let's say, how much? 2000. Let's put 2000. Either you can do it or you can just see it. Either way is fine. Let's put 2000. Click on create streams and outlets on the bottom of your this thing. You can either do it or you can just see it on the screen. It's not necessary, right? It says end of stream processing. Ashish, show the. Look at this way. Okay. You see that so many streams have been defined by considering 2000 hectare as the minimum area for initiating a stream. Right? Ashish, go back. Make it 20,000. 20,000 and 0. It will ask you if you want to delete the previous one, then yes, will delete it. It says end of stream processing. Now if you see 20,000, you see that number of streams have drastically reduced. That means you are saying that you require minimum 20,000 hectares for the stream to initialize. Right? Ideally, it's a trial and error based on whatever is the field condition, to what first order stream you want to actually represent. Right? Now, why it becomes important is, unless you have a first order stream, till then it will only be overland flow. There is a difference between overland flow and channel flow. Overland flow is sheet of water flowing on the surface, on the basic hydrology. Channel flow is it flows in between identifiable banks, so it has the flow characteristics. Right? Now, how do you want to represent is what we consider. So let's say we go with 5,000. We go with 5,000 or 10,000. What are you doing? 5,000, right? Yeah, 5,000. Click on 5,000, 5,700. Click on 5,700 and then create streams and outlets. Now, a stream network, everyone is here, mirrors. Yeah, zoom to one of the outlet. Now you see here, there are two streams that are joining to form a higher order stream. Two first order streams forming to join a second order stream. Now what SWAT automatically does is, before its intersection, before they merge into a common single stream, it creates a surfacing outlet. So wherever two streams are about to join, or from the mask, when it is going out of the mask, it will create an outlet of its own. Go back to it. Right? Put the mask on. Right? Since here the mask is going out, the outlet gets created. Right? And you can see it from your window, that watershed irrigation window that you have. How many number of outlets are created? Yes. You get there or not yet? After the elimination. Yeah, click on that. Yeah, number of outlets are 48. So you have total 48 outlets. Okay? Right, minimize this. Now, you have outlets which are automatically created. But then, to compare any model, there are gauge points which are point measurements. Right? Let's say your measurement is happening here. You cannot compare your outlet from here to here, because there is an additional area that is draining, flow is happening, routing is happening. So there will be a difference in flow from here to here. Right? So we need to add all the gauge points wherever we are adding at the shape file that we have. So in your arc map, click on add data. Go to your input data. Which one, outlet or observation? Outlet. Click on outlet. There is a folder called outlet.shp. Click add. Why did we not present it? Okay, click close. Now you see here, this is a San Joseph watershed in US, in the state of Indiana. It has two gauging points. Zoom on. Click on that. Okay, so it has two gauging points, one here, another one here. Right? Ideally, you want to keep an outlet or a simulation output getting at both the gauging points. Right? Now how do we do that? Open the interface. So here you have different options. Subbasin outlet on the right side, inlet of a draining watershed, and a point source. So we can give a subbasin outlet at all the gauging points that you have. Right? Let's do that. Click on subbasin outlet. Below that there is edit manually, which has add, delete, and redefine. You can go and click add. It will tell you how to do it. It will say left click to add a point, right click to stop editing and save points. Okay? So click OK. Now you zoom to the point where you have the gauge outlet. You can use the mouse to scroll. Now you see here, your gauging point is not falling on your stream. Right? This is because primarily the stream is line is small, but it may be actually falling into this thing. So you can find the closest point to it and you can click on that. Yeah. Go to the other point. Cancel. Zoom out. Go to the other point. Once you add both the points, you click on stop editing. You close the outlets. Now you see here, if you switch switch off the outlets, you can see two red points have been created. Those are the subbasin outlets that you have manually added. Now you have to right click on stop sharing. Right click, yes. It will ask you when you right click to stop editing. You want to save your edits, click on yes. Okay, everyone is here? Yes, no? Yes? Okay. Go back to this thing. Go back. Delete it. Now when you are adding the subbasins, one of the important factor is, in addition to the gate outlets, you must also consider reservoir locations. Wherever the reservoirs are located, you need to add a subbasin outlet. So why that is, the reservoir is simulated at the subbasin outlet. I told you in the previous class, right? Within a subbasin, everything gets added up at a subbasin outlet, and whatever drains from the upstream subbasin will also get added in the subbasin outlet. Now your reservoir is simulated at this subbasin outlet. So let's say you have, just for example, let's say for example you have a reservoir here. There is no reservoir, but if there is a reservoir here, at some point, you make sure that you add a subbasin. Otherwise, your reservoir will not get simulated here, rather it will get simulated somewhere down. So wherever there is a reservoir, wherever there is a sub gauge outlet, you add a subbasin outlet at those locations. Okay? Clear? I think someone was asking about reservoir yesterday. Okay, so you have to add your subbasin outlet there. Okay, go to the schedule. Now, in your outlet and inlet definitions, there are two other things. One is inlet of a draining watershed. This is still, I would still consider San Joseph to a small catchment. But let's say you are simulating something called as Krishna or Godavari. If you want to simulate close to your basin boundary, it's a large area, right? Some lakhs of square kilometers. And many times it's not necessary for us to simulate that entire catchment. So let's say you know you want to simulate only part of the catchment. Just to the right, so let's say you want to simulate only part of the catchment. You are interested in simulating only this region. But while watershed delineating, it delineates the entire catchment. It doesn't delineate only this part. So if you want to simulate only this, you have the information of flow that is entering at this particular point. Then you can give this inlet of a draining watershed. And add a point which can say inlet of a draining watershed. But while simulation, you need to give this what is the stream flow that is coming to this particular point. The time series. Because whatever flow that is coming in will get routed through the stream, and whatever additional water that is coming in will get added, and same will come as outlet. So that is the purpose of inlet of a watershed. So just because you are interested in this particular area, although your catchment is big, don't put a mask and delineate only this part. That is wrong. Flow at this particular point is because of the entire watershed. Now, we know that we are already interested in simulation of this part, and we are also knowing what will be the flow at this particular point. So we will just give the flow here. We'll just give the flow here. Or let's say you are setting up two two different models. Then that's also, you set up a model here, the model is becoming too big for you to simulate in your desktop or in your laptop. Then you break it down into different parts where you have separate model for this, a separate model for this, using inlet of a watershed. Right? Clear? Clear or not? Yes. The third point is point source input. Now let's say there is an interface transfer. Interlinking of rivers. Flow is being transferred from one point to another point. Right? In such cases, you can add this point source input. Let's say some river, adjoining river, we are pumping from a water surplus basin to a water space basin, and it gets that comes here. So you can add a point, and again you need to give the point source input data, how much flow is coming at each time step. Right? At each time step, how much flow is coming, so that gets simulated. Or there is a point source discharge. Some industry is discharging some amount of water regularly, but a domestic sewage is coming on a regular interval. You can add that here as well. Okay. Any point source input to the system can be added using point source. Right? Right now we don't have an inlet draining watershed. We don't have point source input, so we are not considering that. This part is clear? Yes. Any doubts before we go to watershed delineation? No. Okay. Next is you need to select the whole watershed outlet. What is the outlet of the whole watershed? So click on that, select. It will ask you to hold down the left mouse button and drag a box to select outlets. ArcGIS, where it says outlets, you still have to select only one. QGIS allows you to select multiple outlets. Click OK and select the outlet, the last outlet. That's the gauge point. No, reduce the size. Reduce the size actually. Just select this one. Otherwise, 2 will come. Okay. Select that, and it will ask. It will tell you one outlet selected. Yes. Click OK. Done? Everybody is here? Following? Then you click on delineate watershed. Once your outlet is selected, click on delineate watershed. Upstream area, you know at a particular point what is the flow. You don't know the simulate that part. So you just put that part. So the upstream part will not get simulated. You need to give the data of how flow that is coming there. So this part it doesn't simulate. Reducing the calculation limits. You are just saying that at this point I know the flow is flowing. This much amount of flow. Draining watershed? No, you can add. See, once you add, you say. Okay, so you can add some basin, then go to inlet of draining water, then go to point source. It's not like only one river at a time. Okay. Did you get watershed done. Still visible, right? Yes. Okay, it says watershed delineation is done. Can you see the watershed? Now if you see, it has cleaned up other streams which are there. It has identified the area that is draining to this particular point. It has identified the entire area that drains to this particular point, and it has identified the subbasins as well as streams. Go back to the watershed delineator. Now you see, earlier it had 48 outlets. We added 2 more outlets, which made it 50. So the number of outlets in your catchment is 34. The number of subbasins is also 34. Right? No, it's okay. Right? Now once your watershed is done, some of the subbasin parameters must be computed. Right? Basically, slope of subbasin, longest slope or distance, to compute time of concentration and other factors. So all the topographic factors for each subbasin can be computed by clicking on calculate subbasin parameters. There are some options. It says reduced report output. We use it when your catchment is so large that it's difficult to, the computation time is more. Skip stream geometry check. So SWAT creates the stream network based on power law. As more area gets drained, the size of the stream, it uses a trapezoidal channel, and the size of the channel keeps increasing. So it uses more about that, but it can check the geometry check once and skip the longest flow path calculation. You don't need to do that, but it's basically used for various time of concentration. Just click on calculate subbasin parameters. Takes a little bit of time. The more the number of subbasins, more time it will take. But it will do it for all the subbasins. It is there.
Second point.
That will get simulated. Yeah.
Without even check.
What is the second instance? If you are adding inlet or getting watershed, whatever watershed area that drains into that particular point will not be simulated. You need to provide input at this particular point.
And downstream, again, one secondary or primary stream is lining before the delineator. Then the discharge from that stream.
Yeah, it will be simulated. It has to be simulated. Okay? Did we come here? Calculation of subbasin parameters is successful. Click OK if you you have come to this point. Okay, done. Now, once you calculate the subbasin parameters, your add or delete reservoir will get activated. So at this point is where you can add a reservoir for a particular subbasin, or once you have added by mistake, you can always delete it as well. Just click on that. If you click on, it will again, like how you added the subbasin point, same way it will ask you to add a reservoir. Basically, whichever the catchment it is falling, you can click on this, right? Just right left click and stop it. So wherever your reservoir is there, you click it, that particular subbasin will get associated with reservoir, and the end of that subbasin will get added. Okay? Left click and stop it. Oh, don't add. Okay? Okay? Okay, so we'll stop here. It is a delineation. Click exit. Go to your SWAT project setup. Save your SWAT project. Click exit. Go to your SWAT project setup and say save SWAT project. SWAT project setup. Save SWAT project. Okay? All of you have created a folder for yourself. We'll continue. So close the RKS.